In this video, I'm going to show you how to find the characteristical polynomial of a matrix. Let's start with something really simple. So let's start with the 2 by 2 matrix, something pretty easy. And our matrix is going to be 1, 2, -1, -3, something like that. 2 by 2 matrix, like pretty easy. Okay, but also, computing the and finding the characteristic of polynomial of a matrix is pretty easy. So the PA of a matrix, PA lambda, is actually equal to the determinant of that matrix that I'm gonna call A, okay, minus lambda I. And by I mean the identity matrix. So let's just find it, okay? So let's just find lambda I. So lambda I is going to be lambda times the identity matrix. So 1, 0, 0, 1. Remember, the identity matrix is basically the matrix which has 1 on the main diagonal and 0 everywhere else. So these are 2 by 2 identity matrix. A 3 by 3 identity matrix would be the same but with another one here. The 4 by 4 would be the same but with another one here, and so on, and a bunch of 0 everywhere else. So the identity matrix has many useful properties. I'm not going to talk about it much right now, but it actually happens to be very important in linear algebra, and is actually very important in this case as well, of course. So this is basically going to become, think about lambda as a scalar. So we're multiplying a matrix by a scalar. So by a scalar I mean a number. So a scalar, a number, times matrix, basically gonna multiply each and every member of the matrix by that scalar, so that number. So this is gonna become lambda times 1 and so on. So lambda 0, 0, lambda. Pretty straightforward. Okay, so now we have to subtract the matrix A because of this formula. We have to come to calculate the determinant of a newly created matrix, which is A minus lambda I. So I just subtract A to this matrix. Okay, so A minus lambda I is going to be equal to, okay, 1, 2, -1, -3, minus lambda 0, 0, lambda, which is basically, well, we don't know what lambda is, so it just 1 minus lambda, 2, -1, and -3 minus lambda. So this is our newly created matrix, which is fine, because now we can, we know what the characteristical polynomial is for this matrix, because we just have to compute, the PA of lambda is the determinant of this newly created matrix. So of 1 minus lambda, 2, -1, -3 minus lambda. So this is going to be, well, P of A lambda equal to, well, it's a 2 by 2 matrix, so the determinant is just these two guys multiplied minus these two guys multiplied. So 1 minus lambda times -3 minus lambda minus those other two, so -1 times 2, which is gonna give us PA of lambda. This lambda looks horrible. Sorry about that. -3 lambda plus 3 lambda plus lambda square plus 2. Let's rearrange it for the sake of getting this one in front, and getting things right. So our PA lambda, come on, I can get a lambda right. Okay, so lambda square plus 2 lambda minus 1, and this is our solution for the characteristical polynomial of the matrix. All right.